In this problem, we are going to get some practice working with normal curves when you don't explicitly have the average and standard deviation. So the scenario is, suppose you are at a party and you have decided to record the number of words that your fellow students slur over some fixed period of speech. But we've lost the mean and standard deviation. So we want the average, mean, and standard deviation of number of words slurred. But we don't have this information. We do, however, know that we are, at least in this scenario, pretend we have written down 84% slur at least 15 words, and 95% slur less than 30. So what does that look like if I draw a nice normal curve here? It's not that well drawn, but you get the idea. We say 84% slur at least 15 words. That's 15. And let's say, give a nice color. So 84%, we know that this red area is the students who slur at least 15 words. And that's 84%. 4%. We also know that 95 slur less than 30. So say 30 is out here. And this sort of bluish color, we know, so the hatch is going the other way. We know that this area, so it continues all the way over here. So the blue area is 95%. 95% slur less than 30 words. So now we've drawn out our area. So how do we find the mean and standard deviation from this? Well, note that 84%, that's 100 minus 16. And we know that in this area, that means that this area over here is 16%. And that corresponds to a z-score of -1. So 16% in the left tail in the left corresponds to z equals -1. And we also know that 95% to the left, which is what we're given for the less than 30, corresponds to z is 2. So 95% to the left means that z equals 2. So now, what do we do? Just make sure the curve is visible. So it corresponds to z is 2. So now remember that we know that our z-scores are just normalized versions of our data. So the mean, so 15 minus the mean over the standard deviation is equal to -1, and 30 minus the mean over the standard deviation is equal to 2. So now we just have to solve, and I've made the numbers so that they work out nicely. So first we multiply through by the standard deviation and get 15 minus the mean equals negative SD, and 30 minus the mean equals 2 times the standard deviation. Let's make that times. So now I can subtract this from this, right? So the means go away. So I get 45 equals 3 times the, oh, sorry, that's not 45, that's 15. My mistake. 30 minus 15 is 15, so let's just correct that. 15 equals 3 times the standard deviation. So this means that the standard deviation is 5. And now I can just plug in the standard deviation to one of these guys and solve for the mean. So let's just do it in the first one. So we have 15 minus the mean over 5 equals negative 1. So now we can just solve for the mean. I multiply through by 5. I get 15 minus the mean equals negative 5. So now I add 5 to both sides. I get 20 minus the mean equals 0. So the mean is 20. So now the mean is 20 and the standard deviation is 5. And now this means that we can find basically anything we want about how many words a student slurs. So suppose I want to know now what percentage of students slur, I want to know how many slur at least 25 words. Words. Question mark. So what do I have to do? I have to standardize my data. So what z-score is that? 25 minus 20, right? That's the mean. Mean divided by 5. That's the standard deviation. And that's just equal to 1. So what percentage is greater than 1? At z-score, by the empirical rule, we get 16%, right? Because 68% lie within one standard deviation, 68%, and it's symmetric. Well, not the way I drew it, but it is. So 16% lie on either side. And that concludes this problem video.